This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part A of simple interest versus compound interest. In part A, we use the simple interest formula to compute interest on a problem where interest is compounded quarterly. And then in the second video, part B, we're going to use the compound interest formula to find the interest for the exact same problem. We're going to expand on our knowledge of the simple interest formula, I equals PRT, P for principal, R interest rate, T time in years, to find the interest on an account where interest is compounded more frequently. So we're going to do a problem on this video where it's compounded quarterly. So I'll explain what that means as well. So here's the problem. Mary deposits $10,000 at 12% per year. Now we're going to assume this is simple interest unless stated otherwise. Tom deposits $10,000 in an account paying 12%, right? So it seems the same so far, but compounded quarterly. How much interest is earned in each account after 1 year? All right, so what does this mean, compounded quarterly? Instead of waiting till the end of the year and then getting the interest, it means that 4 times a year they compute the interest and now you have more money in your account, and then the next 3 months you have more money in your account to compute the interest so far, etc. So Tom should earn a little bit more money. Now this would be difficult to figure out if it was compounded daily, which is how many banks do it. So we're not going to do that. It would take 365 computations. But we'll do this. It'll take 4 computations, and we'll be able to see the difference between simple interest computed each year compared to compounded more frequently, as in compounded quarterly. So here's the problem. The first one should be easy, Mary. Okay, so part 1 here, Mary. Well, that'll be easy because the principal is $10,000. The rate is 12%. Remember, we're going to write that as either 0.12 or you could write it as a fraction, 12 hundredths. And then the time is simply 1 year. So this should be an easy computation. Her interest will be the principal, $10,000, times the rate. I'm going to just write that as 12 hundredths times 1 year. So the 100 cancels with 2 of those out, and Mary would earn in interest 100 times 12, or $1,200. So that's half the question, and that's the easy part of the question. So Mary earns $1,200 in her account. All right, now Tom is a little bit more complicated because his gets compounded quarterly. So now let's work on that. All right, so how would we figure out Tom's interest after a year? Well, we could use the simple interest formula. Remember, quarterly would mean 4 times a year, right? So 1/4 of 12 months is 3. So that means every 3 months or the time is 1/4, right? 1/4 of a year. That's how often we figure out the interest. Okay, so let's start out with the beginning. So he begins with $10,000, right? And it's compounded quarterly, so it's only 1/4 of a year. So let's figure out that interest to begin with. So his interest would be $12,000, I'm sorry, $10,000 times the interest rate, which is 12 hundredths, right? Times, now what is the time here? It's 1/4. Okay, remember his principal and rate is exactly the same, but you're figuring out how much he's earned after only 3 months. Now, some of you would naturally say, well, if it's 12% per year, it's 3% in 3 months. And that's certainly true, and you could see that happening right here. You end up just doing 10,000 times 300ths or 3%. So from now on, if we want, instead of every time writing 1200ths times 1/4, we know it's just going to be 300ths or 0.03. And I'm not going to do these all by hand. I would suggest you get out a calculator because after a while you'll see that it's going to be easier to not use a calculator. But for this first one, I'm just going to do it because it's simple arithmetic. And we take out the zero. So how much in interest is that? Well, it's 100 times 3. It's $300. Okay, because this is only after 3 months, right? And Mary would have also earned 300 after 3 months, but 300 again after another 3 months, 300 again after the next 3 months, and giving a total of 1,200 after the year. But we only want to know what he's made after the first 3 months. So his interest here is $300. So what happens? After 3 months, he now is going to have $10,300 in the account. So in 3 months from then, you're going to have to compute 3% of this. Okay? So this is after 3 months, right? After 3 months' time, or 1/4 of a year. All right, so this is the beginning. This is after 3 months. He has $10,300. Okay, now we need to figure out how much interest he's going to earn after 3 more months. So we're going to do this again. And now I'm going to use a calculator. It's going to be easier. So again, it's just going to be 10,000. Actually, this one's pretty easy. It's 10,300 now, right? Because now his principal, instead of only being 10,000, is 10,300. And remember that if it's 12% for the whole year, it would be 3% after 3 months. So I think we could do that in our head pretty easily. I'm going to write that as 300ths. Of course, you could write 1,200ths times 1/4, or you could write 0.03 and use a calculator. Again, this is simple enough arithmetic. That 100 cancels those 3's, and I have 103 times 3. If you want to use a calculator, go ahead. I'm just being lazy about getting out my calculator. 103 times 3 is what? $309. Check it out. The first 3 months he only made $300 in interest, but by compounding more often, he now made an extra $9 in interest over what Mary made. So he made this much in interest the next 3 months. So he now has in the account $10,609 after 6 months. That's his new principal. So what I have here is the interest, the 300 and the 309. If it was only asking me interest, those are the numbers I'm interested in. So far, he's made 300 plus $309 in interest. But I need to know the principal in order to do this calculation to figure out what's happening when I'm compounding quarterly. Okay, let's see. I didn't mean to go that far. This takes a lot of computation. Okay, so now we need to figure out the interest here, and I think I'm going to use a calculator this time. So how about I use green again? Just want to vary it. So now the amount of money he has in his account is $10,609. Again, 3% interest. All right, I'm just going to put times 0.03. And when you multiply, if you get out your calculator and you do 10,609 times 0.03, you will get 318.27. Okay, you could also do that, this really wasn't very hard to do in your head as well. But I now have this much in interest. So check it out. For these 3 months, he made $18 more in interest. So I now have, after 9 months, let's see, 10,927, and actually that was 27 over here. I just wrote 29 for some reason. That's how much he has after 9 months. Okay, so I'm running out of room to put 9 months. Let's just 9 months. I'm just going to put the number 9 so you can see it. One more calculation and we'll have up to a year. You can see why you wouldn't want to do this daily for a year. Well, I don't know how many pages you would take. So the amount of interest we're going to get the next 3 months, you get to take it the principal, which is 10,927.27 times 0.03. And now at this point you definitely probably want to get out your calculator. You don't really need to, but you're going to have to round here. It's 327.82. So this could be done without a calculator. I'm just trying to get the point across and not have you do everything by hand. But if you didn't have a calculator, this really isn't very hard to multiply this number times 3. All right, so we've got 327.82. So the total amount in the count happens to be $11,255.09 after 1 year. All right, so it would be easy to figure out how much he earned in interest per year. Originally there was $10,000 and now there's $11,255.09. So you, of course, could just subtract and get $12,555.09. The other way to do it is to add up these 4 numbers that represent the interest: 300, 309, 318.27, and 327.82. I think it's easier to do it the first way I mentioned. So our interest for Tom here, I think his name was Tom. Tom earned $1,255, whereas Mary earned $1,200, if you remember. All right, so by compounding more often, just 4 times a year, instead of just once at the end of the first year, Tom earned $55.09 more in interest. Now you can imagine if you're talking with really huge numbers, it gets bigger and bigger, right? So like if they, each invested $1 million, wow, big difference. And also if you compound, the more often you compound, the more money you will make. All right, so that's an example of how you can use the simple interest formula in order to figure out compound interest, but it can get very tedious. See Part B of Simple Interest versus Compound Interest to see how we're going to use a new formula, the compound interest formula, to compute the interest on this same problem. And it's going to be much faster than doing all the computations we did in Part A. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.